Hello and welcome back. This is part 3 of our centroid discussion. In this video we are going to take what we've learned from parts 1 and 2 about centroids and how to calculate the centroids of some basic shapes, and we're going to see how to combine all of that information to find the centroid of a more complex shape. Often our shapes are not just simple rectangles or triangles or circles, so we need to do more. So to do the centroid of a complex shape, we're going to use these equations right here. So our centroid, once again, has an x location and a y location, and we can set that however we want. I always like to say x is my left, right, y is my up and down. And for a complex shape, our equation is like this. X bar is equal to the sum. This sigma symbol here is simulating in math, or it stands for the sum. So we're adding together our individual shapes, x bar, times our individual shapes area, and we multiply those, and then we add it to the next shape, and then the following shape, and then we divide that by the sum of all of the areas of our shapes. And we do the same thing for y and for our y bar location. Now, what do I mean by our shapes? Well, what I mean by that is we have to look at our total area here and divvy that up into shapes that we know how to calculate the centroid of. So you could do this multiple ways. You might see it differently than I do, but how I'm going to do it for this example is I'm going to split it up into 3 shapes. So I'll have a shape right here. So this is my shape number 1, rectangle 1, and then here is my next shape I'm going to do right here. This will be shape number 2, and this will be shape number 3. Now there are, like I said, there's many ways to do this problem. In fact, I'll show a different way to do this problem in my next video. But for this, we're going to take these 3 shapes and we're going to add the centroids, or use the centroids of all of these to find the centroid of our overall shape. So let's break that down, and then what I like to do for these problems to help me keep things straight is I like to create a little chart, because I think that helps me stay organized. So I'm going to say x bar, y bar, and area, and then I'm going to have shape 1, shape 2, and shape 3 all right in here, and we'll figure out the x bar, the y bar, and the area of each of these shapes. So we'll start with number 1 because that'll be the most straightforward. And as I've said before, I always want to make sure I start here as a 0, 0 point. It helps keep me organized. I assume that everything is in what can be considered the first quadrant, I guess, if you're thinking of it as a sheet of graph paper. So all of our numbers end up being positive. So here's my 0, 0, and we use the relative position of each shape to this 0 point. That's important to keep in mind, and you'll see what I mean here when I get to my next shapes. So for shape 1 touches my 0 point, so I can just go right from there. And again, maybe that's confusing, but we'll see as we go on. So for shape 1, my x bar, since this is a rectangle, my x bar is base over 2. So for shape 1, my base is 3. So this rectangle right here, my base is 3. So I'll do 3 over 2 to get 1.5. I'll make a little line here to separate our areas. Okay. For my y bar for shape 1, it's h over 2. Well, my height is 6, so I'll do h over 2 equals 6 over 2. So my y bar is equal to 3 inches. And then we finally need the area of that shape. Well, the area of a rectangle is base times height equals 6 times 3. So we get our area to be 18 inches. Maybe I'll do it this way, inches squared. 3 inches, 1.5 inches. Okay? There we go. So there's shape 1. Let's do shape 2. So for shape 2, what we need to do is first we need to get ourselves to the location that we're at. So if we're talking about the centroid of shape 2, I need to start at my right angle, but my right angle starts over from 0. So I always need to do the absolute location of this. So what I mean by that is I'm starting actually not at 0, but I'm starting at 3. So here's my location of 3. So I'm going to do it this way. I'm going to write that my centroid is actually starting at 3 plus whatever my centroid location is. So my centroid location is going to be the base over 3 of my rectangle or triangle. Well, since the total is 6 and then this to this point was 3, I know that my base of my triangle has to be 3. So I'll do base over 3 equals, I'll write it down here, 3 over 3. So 3 plus 3 divided by 3 is 1. So I get my location of my centroid to be 4. Now again, 3 over 3 is my actual centroid calculation, but I'm starting at point 3. You can think of it again like a graph. So I'm starting at point 3, so I have to add my centroid location to where I'm actually located in reference to my 0 point. So 3 plus my centroid calculation of 3 over 3 is 4. Okay? For my centroid location of the height of this, again, I'm up from the bottom. My 0 point's on the bottom here. I start up 3. So again, I'm going to go 3 plus height over 3 to get my answer, my equation. So I'll do 3 plus, again, my height. So I would go up 3 to right here. My total is 6, so I know that the height of my triangle is 3. 3 plus 3 over 3, again, is going to be 4 inches. And the area of a triangle is base times height over 2. And so I'm going to do 3 times 3 over 2 to get an area of 4.5 inches squared. Running out of paper there. Okay, 4.5 inches squared for my area of that one. And my third one is a square, 3 by 3. But once again, I have to make sure I'm using the absolute location. Alright, I'm back. Sorry I had to pause my video. I'm recording this with my son at home sick today, and he just woke up from a nap. So if I remember right, I think I'm at number 3, and I was talking about how once again we have to worry about number 3 being in its actual location. So from when we're talking about our x bar, we start from our 0 point, and once again we need to know that we're starting at 3. So I'm going to start by writing 3 plus, and I will say base over 2. So I have 3 plus, and once again, since this overall is 6, and I'm starting at 3, I know that my base of my third shape has to be the same as the base of my triangle, which is 3. So I have 3 plus 3 over 2. So my x bar for this one ends up being 3 over 2 is 1.5, so 4.5 inches. And my y bar, since this shape 3 is starting on the bottom, this is easier this time, so I don't have to go up at all. I just can use the base. So my height of this is 3 over 2, or is 3 inches, and so base over 2, so 3 over 2 equals 1.5 inches, and my area is 3 by 3. 3 by 3, which is 9 inches squared. All right, let's wrap this up. So to find x bar, let's write it over here so we have space. So to find x bar, it's going to be just like this equation up here says, if I move it back a little bit, maybe I'll run out of space. So I'll do x bar over here, sorry. It's the sum of the centroid of your first shape times the area of your first shape plus, in this case, so first shape times the area of our first shape plus the centroid of my second shape times the area of my second shape plus centroid of my third shape times the area of my third shape. And then I take all of that divided by area 1 plus area 2 plus area 3. So how does this look? We'll say 1.5 times 18 plus 4 times 4.5 plus 4.5 times 9, and all of that divided by 18 plus 4.5 plus 9. So if we do that in our calculator, let's see if we can see this again. Once again, I like to make sure that I am plugging everything in using the proper parentheses. So with my calculator, it's kind of nice because I can use my numbers easily. So I'm going to do 1.5 times 18 plus 4 times 4.5. And I know that order of operations should work out this way, but with calculators sometimes it's kind of funky. So we're just going to make sure we're using parentheses properly. 4.5 times 9. And when we do that, we get 85.5. And we're going to take that number divided by, and in parentheses I'll say 18 plus 4.5 plus 9. And I get 2.71 inches. So that is my x bar. Now for y bar, it's going to have a hard time showing up. Let me see if I can do this. It might look kind of funky and cut off some other stuff, but we'll make it work. Okay, y bar is going to be 3. Now we look at my y bar column. 3 times 18 plus 4 times 4.5 plus 1.5 times 9, all divided by, once again, just our areas added together, 18 plus 4.5 plus 9. And when I do all of that, if I use my calculator again, let's just show the work one more time. I do 3 times 18 plus 4 times 4.5 plus 1.5 times 9 equals, divided by, look at that, I get 85.5 again. So if let's just run through it, but I should get the same answer, plus 4.5 plus 9, and once again I get 2.71 inches. So my x bar is 2.71, my y bar is also 2.71 for this entire shape. So there you have it. That is one way to do this. I'm going to do one more example, but I'm going to end this video and I'll do another example in my next video showing yet another way to calculate this using the same equations. We'll just show you one more way to do this so that we can wrap things up and you can have all of the options available to you when you are choosing to do these problems for your homework. So we'll see you in the next video.